Hello, everyone. My name is Eric Ellis. I'm a member of Group 4 for BE1500, and our data set was plane crashes from 1908 till 2009. And the questions we really want to answer was how safe is air travel, especially since in the earlier years, is it better than it was before, or are we getting worse over time? And if you look at the data set here, what we did was we load this all as column vectors because we're going to need all of these, so we might as well just load them as column vectors, and I'll show you that. We're going to jump right into MATLAB and show you that here. So you look here, we just load them with XLS read. Anything that's a string is with this little tilde here, and then everything else is just going to be a normal arithmetic column vector. And then we just initialize start year and end year. Obviously, we're going to be able to manipulate this with with one of our functions where you're going to be able to pick a range. I'll show you that later on. Now, this is a little interesting. What we did here is we used datevec for date, and so which was one of the column vectors. And this is so that we only get the years, because if you look at the date here, we got days and months, and we really don't need that. It's much easier just to work with years, and it's much more clean since it's already such a broad data set. And then this unique year operator and unique year here is what it's going to do is it's going to create a two-column matrix in which in the first column is going to have all the years that a crash occurred from 1908 to 2009, and then the second column is actually going to have the number of times that that year appeared, which should tell you how many times a crash occurred during that year. And this is important because not all years are represented. We're missing 1909, 1910, 1911, and 1914. The data set didn't have them. I'm also assuming that probably wasn't airplane crashes because there probably wasn't a lot of plane crashes and planes in general during that time. So this will give us, so that it'll ignore those values, and also tell us the number of times a crash occurred in a year. And then we're just going to enter the menu. So what we're going to do here is going to be our choices of our different questions to determine how safe air travel is. And it's going to be from 1 to 8, which will assign the value for selection, and we'll enter this while loop. If you select 8, which is the exit, it'll be greater than the while loop and you exit the program. And otherwise, it'll just keep rotating through the menu here and just keep going as you select different values here. So we're just going to run her here and just we're going to get her going. So it's going to take a second, just got to load all those column vectors up, and then it's going to pop up here. So our first choice here is what year had the most crashes. Very simple. All this is doing is it's using that same trick where it determines the number of times a crash occurred per year, and then just makes a histogram of that. And then we're using a max function with a for loop in order to determine that it was 1972 that had the most crashes, and it was 104. And that's just matching up what year had the largest, and you can just kind of see that in the histogram. You can also do this just to get a broad idea of the data, how many deaths you're working with for a certain year. So if you're picking like between 1920 and 1930, it's good to get just a general view of that. And that's just all that how that's working. For the next one, another very simple one is what time a plane occurred crash, what time a plane crashed, sorry. And that's from 1 to 24 military time. It's the way the data set gave it to us. And also it's much more clear. If you got 9 p.m. or 9 a.m., it's really hard to distinguish those two. But with the 24-hour clock, it's much simpler. And this is working the same thing with that datevec function, except we're only selecting the hours instead of the years out of that function. And then it just plots it just like normal, where we're taking the number of crashes, same function as before, determine the number of times that number appeared, and then it adds it together. Very, very simple. Next, we're going to go into what most likely was for your state to crash. This is going to make a table, so we're going to go into this one here a little bit. You had to make a vector in which it had a string of all the states. And what it's going to do is it's going to go through the location vector that we loaded earlier in the program, right at the very beginning. And it's going to go through, it's going to compare them all. It's going to compare all 50 states to the location vector so we can determine how many times that a crash occurred in that state. And it's really convenient because we know there's exactly 50 states, so the loop only has to run 50 times. Perfect. And it's just going to do that. It's going to print that nice thing right here down at the command window here. You're going to have all the states and the number of times they crashed. And then below this, if we go back up here for a second, we're just going to do another for loop to determine what year, state had the most crashes and with how many plane crashes. These will also change once again once we start trimming the years down, and you'll get more zeros where there hasn't been a plane crash in a very long time. It's the same procedure here. So let's just go back to the window here, and we're going to go to how many people died within a certain year. This is also very useful just so that we can get general ballpark numbers. So like say how many people actually crashed in the 30s or the 40s, or how many people crashed in the last 20 years. It's very simple to figure out how many people actually died, and then we can get an average of that. We can look at that very quickly. And essentially all it's going to do is to start year as end year. It's going to enter this function called crash deaths, and it's just going to It's going to essentially do an addition for loop where it's just going to add them all together as they come through. And so you're going to add them all together. You're going to compare them. Then you're going to use an average. Boom, you get the average deaths, and just plot it to the command window. Very, very simple, but very useful. Now we're going to go into something of a little more detail of percent survival rate. So what are your chances that you're in a plane crash, and what's your chances of dying? If you look through the data set here, it has this nice little graph here, and it has all the date range that you want. But if you notice here, there's also this red line. This red line is the trend line. So there, it essentially gives you a nice function, so that way you can essentially plot where your chance of survival. If you look here, you notice first off that it's actually trending downward, which means that plane travel has actually gotten less likely to survive than it was in previous years, which is a little disconcerting. But this is the kind of thing you can learn from big data sets like this. And it also prints to the command window that actual formula here, so we can actually see right down here. I'm highlighting it here for you. That we have it as a two-order linear. The two-order plot, because it just fits the data set the best, and it actually other higher orders just make it much more messy. So that's what we finally did. So you can actually use this to plot and actually trend. Well, does this trend hold? Does it go into 2010, 2011, 2012, 2013? You can actually do that and plot it and actually see that type of thing. And we can go directly into it, so we can take a look at it a little bit. So all we're doing here is we're taking the number of people aboard a plane. So here, I'll go into the actual function itself, because that's a little more important here. We're taking the number of people that were aboard a plane and the number of people who died on a plane, and we're essentially just making a percent chance. So we're making a nice little for loop. We're going from year to year to year, which is just new unique year. Remember, we're missing years. We're missing 1909, 1910, 1911, 1914. So we actually need to scooch it in a little bit. And then all we're doing is we're getting that rate. So what's that percentage chance? So the number of deaths divided by the number of people aboard a year times 100 will give you that percent chance. And that feeds back into the original script here. And we're just removing those dates once again that are going to happen from the accumulate rate. And then we're just going to plot it using polyfit and polyval to actually get that trend line and to get that data set, and then just print it with fprintf. Next is something a little less, is what operators had a crash. Oh, I just ran it. Is what operators had a crash, and how many crashes did they have? Now, this is going to take a little while, as the warning at the bottom says here, is because it actually has to use a string compare for extremely long named things. So like U.S. military, or like the military station of like the North Sea or something like that. Very large string. So when it goes to compare it, it's going to take a little bit of time, but essentially works the same as what we did for the unique years and the years. Is essentially just using string compare, and the number of times that string appears. We'll actually go into the function here. The number of times that this string actually appears, string compare of unique year to the operator, and it just adds it to the crashes. So it just adds it over and over again. So you're just going to make a table, 2 columns. One column is going to have all the operators that are crashes, and the other one's going to have the number of times that string appeared in that, and just going to be a nested for loop in order to do that. Very simple, but pretty interesting to see what companies and what people who fly planes commercially, what ones are the most dangerous to do. So now we're going to go into year selection, which is the bread and butter of this program here. In year selection, we're going to reload the data set here, and that's just in case someone wants to do multiple data sets selections in the same run of the program. So we're just going to have to reload it. So that's what this process here is actually, just to reload it so that we can go and change it. Here we go, just finished loading. So as you see here, right, this is like different operators, and this is the number of crashes that occurred. Very, very simple, and this list is quite long. This is also saved under a chart, so you can under a table, so you can actually see it later. So let's go to the year selection, just run it through really quick. So let's change the date range, and let's pick something like 1920 to 1930. So what was your chance of survival from 1920 to 1930, right? So now the date range is set to 1920 to 1930, as it says at the bottom here. Let's go back to that percent survival rate, and it's going to load that through here. And now you're going to see it's only the date selections between 1920 and 1930. You actually see that it's stalled out here, which is interesting, the trend line. And we can even do that with multiple things. So let's see what year had the most crashes. And it looks like the year that had the most crashes was 1929, and 1929 with 37 crashes. And see that it affects all the data set that is in this program. And the way that works is essentially what we're doing is we're using this giant function called date restriction, in which we're we're taking in all of the column vectors that were in the year, and we're shortening. We're counting the number of times that that year appears in the. Is it just? Sorry about that, folks. Just it cut out there because Loom only has a 10-minute limit. So going through here, what we're doing is we were looking through a year selection. So what it's going to do is essentially it's going to take the input from the main script of what years they want, and also the restriction that you can't use years 1909 to 1911 to 1914. And then it's going to enter this giant function called year selection. And in this function, what we're going to do is we're going to load all of the column vectors that we had. And then we're going to enter a bunch of if statements. These if statements are just so that way people don't pick an end year that's greater, that's less than the start year and things like that. And it's just restrictions. And then what it's essentially going to do is it's going to remove all of the years in which we're not needed. So it's going to use that same principle of it's going to count the number of times a year appears. And then it's also going to count the number of times a year appears all the way until your end year. And then what it's going to do is it's actually just going to remove the years in which you don't want. So it's going to say there's 36 crashes in between the year for the start of your year, and then to get all the way to the other end of the year is 140 crashes. It uses those two numbers to determine that it has to take out that many rows of the column vector, and then it restricts those for the entire data set. If you look here, see it's date, abroad, fatalities. It actually just does the whole shebang. And what that does is that affects all the programs in the main script, right? Because they were loading those column vectors direct. So if I change those column vectors, then those column vectors are shorter, and then it only has that data set to work with. And essentially what you can do is you can build an entire arrays of data that you want, because say you only want data from 1930 to 1940, you can totally do that. And that's essentially how they all interact with each other. And I think this was a really good project for our final project, because we learned so much. We had to work together, use similar variables for things, and also the fact that we had to use if statements, while loops, for loops, nested loops, the whole nines. It was quite a good program, and really taught us what we could do, because there wasn't a way to manually handle all of that data. So very good. So thanks for listening to my presentation, my little video here, and have a good one.